In this video, we're going to be talking about the electromagnetic spectrum. So, the sun produces these waves through the process of nuclear fission inside of its core. From there, it makes its way towards its outermost region, and from there, it radiates through a vacuum, which is space, and enters into our Earth. And this comes in the form of electromagnetic radiation. So these electromagnetic waves move through that vacuum and eventually go into our atmosphere called electromagnetic radiation. Most of these waves are natural, but some of them are being produced by human technologies. And I'm going to be talking about each different part of the electromagnetic spectrum. So if the particle that's driving this wave, if it's vibrating a lot, then it creates a higher frequency, which creates a shorter wavelength. But if it's not vibrating that much, it creates a longer wavelength but a shorter frequency, and there's not going to be that much energy. Some examples of this not having not having that much frequency would be radio waves, but some of having a higher frequency would be gamma rays. So we're going to be looking at each of the rays individually. There's 7 different types of electromagnetic or EM waves. We're first going to be starting off with radio waves. So radio waves are the ones with the longest wavelength. These wavelengths can be as big as mountains or buildings. And the thing is that these wavelengths are mainly used for communication and can also be used in broadcasting. Because of their wavelength, they're able to travel a further distance on Earth. Because they're able to travel that further distance, people are able to communicate from longer distances rather than having to travel all the way. Some areas where this can mainly be used is like GPS tracking. The thing is that the GPS uses satellite communication, and since the radio waves are that long, they're able to communicate with the satellite and are then able to communicate to the GPS, giving you real-time location. Also, they can be found in Wi-Fi, Bluetooth, and like I said, navigation. Next are microwaves. Microwaves are not as big as buildings. They could probably be as big as a few grains of sugar. Now, the radio waves didn't cause no danger. However, microwaves can cause some internal tissue damage and maybe some cells. Like it could damage some cells. They're mainly used in cooking. So for example, if we take the microwave we have, what happens is the microwaves are entering into the food, and what happens is, since that thermal energy is so high with the microwaves, it causes all the water inside the food to evaporate, which makes the food hot when we get it out of the microwave. Microwaves could also be found again with satellites, but can also be used in mobile phone communication. Next is infrared waves. They can also cause skin burn, and they're around the size of a protozoan. Protozoan is a type of bacteria. Infrared waves typically are found in heaters such as ovens, and could also be found in night vision equipment. They could also be found in TV remote controls. Now, there are a few animals that actually are able to see infrared waves unlike us. Things like snakes, like bats, mosquitoes, and certain fish can see infrared light. And the reason why is probably because they're mostly nocturnal and need to see during the night. Also, the thing about infrared is that we release very small specks, like very small specks. This happens throughout the day, but we can mainly see this happening throughout the night. The next part is visible light. Visible light doesn't have any danger. Typically, it would have danger, but the thing is that because of the ozone layer in our atmosphere, it's able to filter out that danger. If we don't have the ozone layer, it's damaging the DNA in our cells. So typically, if there's no ozone layer, the visible light would damage us. However, because the ozone layer is there, it's not damaging us, it's filtering it out. It's the only part of the spectrum that we can actually see. However, these animals will be able to see more different types of waves, but this is the only part of the spectrum we can see. Visible light comes in the size of a few bacteria, and they're mainly used in things like human vision and photography. Next is ultraviolet waves. They can damage our eyes and can cause skin cancer. So since ultraviolet rays come at a very high intensity of heat, what happens is that when it's like too hot, the skin produces something called melanin. Melanin is, because it's produced by the skin, it's what creates the tans that we have when we're outside in the sun too long. And because it's producing that, if we produce more and more and too much melanin, then what happens is that it eventually causes skin cancer. Now, the ultraviolet waves typically come in the size of a few molecules, and they really originate from the sun. Some example over here of some Some animals that are able to see ultraviolet waves would be bees. Next is X-ray waves. X-ray waves can also damage cells and can also lead to skin cancer. They're around the size of an atom, which is less than molecules, and the only reason why we use X-ray waves is mainly for medical equipment. If doctors need to figure out what's happening inside our body, they mainly use X-rays to be able to get an internal view of everything that's happening. Typically, like when we get a broken bone, they would mostly use the X-ray. However, if our skin is exposed too much to the X-ray, it can also lead to cancer, so we have to be careful with it. And lastly, we have gamma rays. Gamma rays are extremely dangerous. Gamma rays are only used for sterilizing food and medical equipment. And by sterilizing, that means like killing all the germs and bacteria inside of it. The thing about gamma rays is since it has such a high frequency, our bodies are not able to handle it, hence leading to the cancer, or it could even kill us essentially. Size of a gamma ray is around the nucleus of an atom. So the nucleus of an atom would be like only the protons and neutrons, not including the electrons. This is the 7 different types of electromagnetic spectrum waves. First, we have radio waves, which do not cause danger to us, and they're around the size of buildings or mountains, and are mainly used for communication and broadcasting. Next, we have microwaves, which can cause some internal damage to our tissues because they're too hot, and the thing is that they're around the size of grains of sugar and mainly used for cooking food. Next, we have infrared rays, which can cause skin burns. They're around the size of protozoa, and the thing is that they're mainly used in heater, and night vision equipment. They can also be found in some kind of technology, and a few animals are able to see it, mainly animals that go out at night. Then we have visible light, which is the only part of the spectrum that we can see. They cause no danger because of our ozone layer that filters out the visible light, and they're mainly used for human vision photography. Then lastly, we have ultraviolet. Ultraviolet is around the size of a molecule, mainly comes from the sun, and their real purpose is they're just too hot for us, and they're mainly used for like thermal heating and all that. Bees are like one of the only animals that could see ultraviolet waves. Next, we have X-rays, which are around the size of atoms, mainly used for medical equipment. And lastly, we have gamma rays, which are around the size of an atomic nucleus, which includes protons and neutrons. And they're mainly used for sterilizing food and medical equipment and killing the germs that could be located on it. And the thing about visible light, it's split into 7 different colors: red, orange, yellow, green, blue, indigo, and violet. All right, and now let's do a small demonstration. So we have this prism over here. The thing about this prism is that when light is focused on it, it refracts the light and splits it into multiple colors. So we're able to see multiple colors from it. And this is because when white light hits this clear part, it then releases these colors. And that's actually what our eyes do. So now we're going to be showing 3, 2, 1. We can see that the light from the source, which is a flashlight, is hitting the clear part, which is then reflecting all of this colors at the end over there. So you can see at the top over there, it's showing all the colors, the rainbow colors, which is what the visible light actually has. You can see at the top over there.